There's a mechanic in Louisiana who refuses to sell new outboards, not because he can't, because he says it would be dishonest. While the industry pushes bigger engines, more horsepower, and higher price tags, something strange is happening in boatyards across America. Dealers are scrambling to move brand new inventory, but used Mercurys from 10, even 20 years ago, they're selling in days, sometimes hours. And the people buying them aren't amateurs. They're charter captains, commercial fishermen, mechanics who've seen it all. They know something the marketing departments don't want you to find out. Today, we're going to show you exactly what they know and why the smartest outboard purchase you'll ever make might already have 1,000 hours on it. Walk into any boat show in America today, and you'll be surrounded by a very specific message. Bigger is better. Newer is smarter. And if you're not running the latest technology, you're somehow falling behind. The marine industry has spent the last decade in an arms race. Mercury unveiled the V12 Verado, a 600 horsepower monster that costs more than most family sedans. Yamaha answered with the XTO Offshore, a 425 horsepower beast designed to dominate blue water. Seven Marine pushed even further, building engines that belong on super yachts and carry price tags to match. And the marketing has been relentless. Every new model promises revolutionary performance, unprecedented efficiency, technology that will transform your time on the water. But here's what the brochures don't mention. Since 2019, the average price of a new outboard motor has climbed by 47%. That's not inflation. That's strategy. Manufacturers have repositioned outboards as premium products, loaded with features that sound impressive in advertisements, but raise serious questions in repair shops. And the data tells a troubling story. According to training materials circulated among marine mechanics, warranty claims on first-year engines have increased by more than 20% across the industry. Brand new outboards, fresh from the factory, are failing at rates that would have been unacceptable a generation ago. The question is why? The answer lies in complexity. Modern outboards are engineering marvels. There's no denying that. Fly-by-wire throttle systems have replaced mechanical cables. Digital shift controls have eliminated traditional linkages. Integrated electronics monitor everything from fuel flow to GPS position, adjusting performance in real time. But every sensor is a potential point of failure. Every circuit board is a component that can corrode in salt air. Every software system is a layer of technology between you and a simple, reliable engine. A mechanic in the Florida Keys put it bluntly. He said he's got customers bringing in 3-year-old outboards with corroded wiring harnesses, failed engine control units, and throttle bodies that cost $1,800 to replace. Meanwhile, he's got a 2006 Optimax on a commercial shrimp boat with 6,000 hours on it. That engine just needs spark plugs and an oil change, and it'll run another 6,000. This isn't about rejecting progress. It's about understanding a trade-off that the industry doesn't advertise. The average recreational boater puts 50 to 100 hours on their engine each year. That means most outboards will never come close to reaching their true lifespan potential. They'll be traded in, upgraded, or replaced long before the powerhead shows any real wear. But for the buyers who keep their boats, who measure ownership in decades instead of seasons, the calculus looks very different. And that's where the 10 engines in this video come in. These aren't antiques. They're not museum pieces or collector's items. They're outboards built during a specific window in Mercury's history. A window when the engineers had solved the major reliability problems, but before the accountants and marketing teams started adding complexity to justify higher prices. These engines represent a sweet spot. A moment when durability, simplicity, and performance aligned in ways that the current generation of outboards often can't match. The mechanics know it, the charter captains know it. The commercial fishermen who depend on their equipment every single day know it. And by the end of this video, you'll know it too. Let's start with the engine that professionals call the cockroach. Because no matter what you do to it, it absolutely refuses to die. The first engine on our list is the Mercury 9.9 and 15 horsepower four-stroke, specifically the models built between 2006 and 2014. In the outboard world, small kicker motors rarely get much attention, but this one has earned a reputation that defies its size. The foundation of this engine is a Tohatsu block, refined with Mercury's fuel system engineering. It uses a simple carburetor design with no electronic fuel injection and minimal sensors. But the real secret is inside. Mercury's engineers installed an oversized water pump impeller relative to the engine's displacement. That means it runs cool even in brackish, debris-filled water, where other small outboards overheat and fail. Commercial crab pot operators in the Chesapeake Bay have documented more than 8,000 hours on these little engines without major rebuilds. 8,000 hours on a kicker motor. The current used market price sits between $1,800 and $2,400. A comparable new engine costs more than $4,000. When you're looking for one, search for serial numbers beginning with 1B366, which indicates production at Mercury's Fond du Lac plant. And avoid anything made after 2015, when cost-cutting reduced the impeller size and compromised cooling performance. The second engine is the Mercury 40, 50, and 60 horsepower EFI four-stroke from the Bigfoot era, built between 2005 and 2012. This is the engine charter captains quietly recommend to each other when no one from the dealership is listening. The electronic fuel injection system on these models used a redundant sensor array specifically designed for commercial abuse. Unlike later integrated units, each module could be replaced separately. But here's what makes it truly special. The powerhead was originally engineered for a 75 horsepower application. Mercury detuned it for the smaller models, which means internal stresses never come close to design limits. A mechanic in the Florida Keys said he's rebuilt one of these exactly once in 18 years. And that was only because the owner ran it completely dry of oil. Used prices range from $3,500 to $5,200. Engine number 3 is the Mercury 75, 90, and 115 horsepower Optimax, specifically the 2004 through 2012 models. This is where the list gets controversial. When Mercury introduced Optimax direct injection in the late 1990s, early versions had problems: injector fouling, air compressor failures. The technology was promising but unproven. By 2004, those issues were solved. The third-generation Optimax delivered two-stroke power with four-stroke efficiency, and the air compressor that once caused headaches had been over-engineered into near-permanent reliability. These engines were discontinued not because they failed, but because EPA emissions standards pushed the industry toward four strokes. Many mechanics believe they were abandoned too soon. Used prices run between $4,800 and $7,500. The fourth engine is the larger sibling, the Mercury 135 and 150 horsepower Optimax from 2005 through 2014. This 2.5-liter V6 powered more charter boats, guide services, and fishing tournaments than any other outboard of its era. Mercury designed these with a wet sump oil system that maintains lubrication even at extreme tilt angles. A Louisiana redfish guide documented 11,400 hours on his 2007 model before needing any major work. That's more hours than most recreational boaters will see in a lifetime. Used prices range from $6,500 to $9,000. The fifth engine is perhaps the most misunderstood on our list. The first-generation supercharged Verado, specifically the 200, 225, 250, and 275 horsepower models built between 2008 and 2016. Early Verados from 2004 to 2007 had real problems, but the refined second generation fixed every major issue. The Verado's supercharger provides instant throttle response while allowing the engine to cruise at lower RPMs. That design reduces internal wear by roughly 30% compared to naturally aspirated competitors running at equivalent speeds. And the closed-loop cooling system isolates the powerhead entirely from corrosive salt water. Mechanics who've torn these engines down after 3,000 hours report internal components that still look factory fresh. The problem is perception. Buyers remember the early Verado failures and assume all first-generation models share those flaws. They don't. The 2008 through 2016 units represent some of the best engineering Mercury has ever produced. Used prices range from $12,000 to $18,000. A new Verado with comparable horsepower costs nearly $30,000. Now we move into different territory. The next 5 engines aren't just reliable. They're the ones the industry tried to forget. Engine number 6 is the Mercury 200 and 225 horsepower EFI V6. The 3.0-liter models built between 1994 and 2001. Mechanics call this one the cockroach because it simply will not die. Before Optimax, before Verado, before any of the modern technology, Mercury built a carbureted 2-stroke V6 that became the backbone of commercial fishing fleets around the world. There are virtually no electronics beyond basic ignition. The fuel delivery system is as simple as outboard engineering gets, and parts remain universally available, often from sources outside the marine industry entirely. Commercial shrimpers in the Gulf of Mexico have documented engines from the mid-1990s still running on original powerheads with more than 15,000 hours. The lower unit gearing was designed for continuous operation at 4,200 RPM, the kind of duty cycle that would destroy most modern recreational outboards within a few seasons. Used prices sit between $2,500 and $4,500. The 7th engine is the Mercury and Mariner 25 horsepower 4-stroke built between 2001 and 2010. This is a rebadged Tohatsu, and Tohatsu's 25 horsepower is considered one of the most reliable small outboards ever manufactured. Mercury's version added improved anodes and better water pump housing, but the heart of the engine remained unchanged. The single-cylinder design means fewer moving parts and straightforward maintenance. The crankshaft is forged steel rather than cast, dramatically overbuilt for the horsepower rating. When Mercury eventually developed their own 25 horsepower to replace this model, mechanics widely agreed the Tohatsu-based version remained superior for longevity. Used prices range from $2,000 to $3,200. Engine number 8 is the Mercury 225 and 250 horsepower Pro XS Optimax from 2010 through 2018. This engine was marketed to base tournament anglers chasing hole-shot speed and top-end performance. But commercial operators discovered something the marketing never mentioned. The same tuning that made the Pro XS fast also made it remarkably fuel-efficient at cruising speeds. The 3.0-liter V6 block is shared with the standard Optimax, but the Pro XS uses a different lower unit gear ratio and ECU calibration that actually reduces strain during continuous operation. Here's what Mercury never publicized. Starting in 2010, Pro XS models received upgraded connecting rods and crankshaft bearings. The change was never announced because acknowledging it would have implied earlier models were inadequate. But mechanics know. And they specifically seek out the 2010 and later units for customers who need an engine they can trust. Used prices range from $9,000 to $14,000. When buying, verify the engine is a genuine Pro XS by checking cowl badging and the serial number. Some sellers rebadge standard Optimax units to command higher prices. The 9th engine on our list is the most recent and the most controversial inclusion. The Mercury 4.5-liter V6 4-stroke, specifically the 200, 225, and 250 horsepower models built between 2018 and 2022. This engine is only a few years old, which makes its inclusion here unusual. But mechanics are already seeing patterns that suggest this platform could become Mercury's next long-term workhorse. Unlike the Verado, this is a naturally aspirated design. No supercharger, no complex boost system. It was Mercury's direct response to Yamaha's dominant F200, F225, and F250 lineup, and early reliability data has been exceptional. The reason comes down to intent. Mercury designed this engine specifically for the high-hour commercial market. Ferry operators, dive boat companies, charter fleets that measure runtime in thousands of hours per year. The consumer versions sold at dealerships are mechanically identical, which means recreational buyers are getting commercial-grade internals without paying commercial prices. The 2018 through 2020 models are now appearing on the used market at discounts approaching 35%. For buyers willing to accept a few hundred hours on an engine built to run for thousands, this may represent the best value in modern outboards. Used prices range from $14,000 to $19,000. Look for documented service history showing proper break-in procedures during the first 100 hours. The 10th and final engine is the Mercury 150 horsepower 4-stroke, the inline 4-cylinder models built between 2011 and 2018. While Mercury promoted the Verado as its premium 4-stroke, this engine quietly became the best-selling mid-range outboard in North America. It earned that position not through marketing, but through mechanical honesty. The 4-cylinder design incorporates a balance shaft for smooth operation. The port fuel injection system is proven and simple, deliberately avoiding the complexity of direct injection. Parts are shared across the 115, 135, and 150 4-stroke lineup, which guarantees long-term parts availability for decades to come. This engine was designed by Mercury's European engineering team, which prioritized fuel economy and longevity over peak horsepower numbers. The result is an outboard that sips fuel at cruising speeds and rarely requires anything beyond routine maintenance. Rental boat fleets in the Great Lakes report average lifespans exceeding 5,000 hours with standard service intervals. Used prices range from $8,500 to $12,000. So those are the 10 engines, but knowing which outboards to look for is only half the story. The real question is why these specific motors outperform their newer, more expensive replacements. The answer begins with a fundamental shift in engineering philosophy. 20 years ago, outboard manufacturers designed engines with a simple goal: build it to last 5,000 hours. That was the benchmark. That was the expectation. Engineers spec'd components to survive decades of hard use because they assumed owners would keep these machines running for as long as possible. Today, the goal has changed. Modern outboards are designed to last past the warranty period. 3 years, 5 years at most. After that, the engineering calculations become someone else's problem. This isn't planned obsolescence in the traditional sense. These engines aren't designed to fail, but they're not designed to be repaired either. When a sensor fails on a 2023 outboard, you often can't replace just that sensor. You replace the entire integrated module. A repair that would cost $200 on a 2010 Optimax can cost $2,000 on a current year model, because the engineers no longer assume mechanics will be servicing these machines for decades. The industry has shifted from building durable equipment to building sophisticated products. That distinction matters. There's a concept in engineering called the sweet spot. It describes the window when a manufacturer has solved the early generation problems, but before cost-cutting and feature creep begin to degrade reliability. Every engine family has one. And for Mercury outboards, the 10 models we've covered today represent exactly that window. Understanding this creates an advantage that most buyers never realize they have. The dealers won't tell you about it. New engine sales drive dealership profitability. Warranty work generates more revenue than used engine repairs. Marketing budgets flow toward new products, not legacy support. The entire industry is structured to push you toward the showroom floor. not the service dock where a 20-year-old Optimax is getting its spark plugs changed. But the mechanics know. The charter captains know. And now you know too. So how do you act on this knowledge? When evaluating any used Mercury outboard, 5 factors separate a smart purchase from an expensive mistake. First, demand documented hour meter readings. Not just a single number, but photographs over time if possible. Hours can be reset. Engines can be misrepresented. Documentation creates accountability. Second, require a compression test with specific results. For Optimax engines, you want readings above 115 psi across all cylinders, with no more than 10% variation between them. For 4 strokes, the threshold is 150 psi. Any significant deviation indicates internal wear that will become expensive. Third, inspect the lower unit oil. Pull the drain plug yourself and examine what comes out. Clean oil means a healthy gear case. Milky oil means water intrusion, which means damaged seals and potentially corroded bearings. Walk away from any engine with milky lower unit oil, regardless of price. Fourth, verify service records showing water pump impeller and thermostat replacements. These are maintenance items that directly affect engine longevity. An owner who neglected these basics likely neglected other critical services as well. Fifth, visually inspect the anodes and power head for corrosion. Saltwater is relentless. Even well-maintained engines show wear over time, but heavy corrosion on external components suggests internal damage you cannot see. Where do you find these engines? The best deals rarely come from classified advertisements or online marketplaces. Private sellers often have inflated expectations based on emotional attachment rather than market reality. Instead, look for commercial operators upgrading their fleets. Charter companies, fishing guides, and rental operations cycle through equipment on predictable schedules. They maintain meticulous records because downtime costs them money. And they price equipment to move because storage costs them money too. Estate sales and marina liquidations are also prime sources. When a boater passes away or a business closes, executors typically want quick, clean transactions. They're not emotionally invested in the equipment. They just want it gone. The marine industry will continue building bigger, faster, and more complex engines. Some of them will be extraordinary achievements of engineering. The horsepower wars show no signs of slowing down, and technology will keep advancing in ways we cannot predict. But for buyers who value reliability over bragging rights, who measure success in hours on the water rather than numbers on a spec sheet, the smartest purchase might already have 1,000 hours behind it. These 10 engines weren't built to be disposable. They were built by engineers who assumed you'd want to run them for 20 years. Engineers who overspec'd the bearings, who designed cooling systems with margin for error, who chose simplicity over features because simplicity survives. That philosophy has become rare. And that's exactly why these outboards remain valuable. Sometimes the best technology isn't the newest. It's the technology that was built to last, and then quietly forgotten by everyone except the people who depend on it every single day.